Hi, welcome back to Data Science by Raw Fabric. And today, let us look at how to sample data and what is data sampling. Sampling is a method that allows us to get information about the population based on the statistics from a subset of the population, which is the sample data, without having to investigate every individual. This is to save some time and space, because if we can come to a conclusion on a sample, we can justify it towards the whole population. Why do we do data sampling? Sampling is done to draw conclusions about populations from samples, and it enables us to determine a population's characteristics by directly observing only a proportion of the population. Selecting a sample requires less time than selecting every item in a population. Sample selection is a cost-efficient method, and it helps us analyze the data in a less cumbersome and more practical way than analyzing the entire population. These are the following steps in data sampling. First, let us identify the population or the target problem. Next, let us select the sampling frame. It is the list of people containing the target population that form the population. Next up, we need to choose a sampling method. We either can go with the probability approach of sampling, or we can go with a non-probability sampling. Do keep in mind that using non-probability sampling will yield in more bias, and you need to have an expert opinion about the population. Next up, we need to determine the sampling size. Lastly, after everything is set in place, we gotta collect the required data so that we can perform statistics and probability. Now let us look at the different types of data sampling. First, we have the probability sampling, where every element in the population has an equal chance of being selected. The four types of probability sampling are simple random, systematic, stratified, and cluster-based data sampling. In non-probability sampling, every element in the population does not have an equal chance of being selected. The four types of non-probabilistic sampling are convenience, coda, judgment, and snowball. In probabilistic data sampling, first we have simple random, which, as the word says, every element in the population is randomly chosen at equal probability. For example, if there are 100 data points, every element in the dataset has the equal probability of randomly being chosen, which is 1%. Next up, in probability sampling, we have systematic sampling. Systematic sampling has a pattern to do the randomness. Next up, in probability sampling, we have stratified sampling. Stratified sampling, unlike simple random and systematic sampling, has two steps. First, we divide our population into subgroups or different classes. After we divide our population into subgroups, then we pick from each color. The amount of events we pick from each color depends on the proportion of their numbers in the population. As we can see in the example, blue has more events, so that's why we take 2 events from blue, whereas from red, yellow, and green we only take 1 each. Lastly, we have cluster sampling. Cluster sampling is very well used in machine learning. Cluster sampling subgroups all of its population and selects one of the subgroups. In the example, we take the fourth subgroup, which is 13, 14, 15, 16. Now let us look at non-probabilistic sampling. The first one is convenience sampling, perhaps the most easiest method of sampling because events are picked based on their availability and willingness to take part. Convenience sampling is prone to heavy bias. In the example below, we can see that only green, red, and yellow got picked, and none of the blue events got picked. Next up, in non-probability sampling, we have coda sampling. In this type of sampling, we choose items based on the predetermined characteristics of the population. Consider that we have to select individuals having the similar characteristics. In the example below, we selected all the events which have the number of multiplicity of 4. We have 4, 8, 12, 16, and 20. Coda sampling is also prone to bias because it can overlook some of the data in the population. Next, we have judgment sampling. Judgment sampling is also known as selective sampling. It depends on the judgment of the experts who are picking the events from the population. Judgment sampling can be prone to bias as is based on the judgment of the individual who's picking the data from the population. In the example, we can see that only red, green, and yellow events were selected by the expert, and none of the blue events were selected. Lastly, in non-probabilistic sampling, we have snowball sampling. Existing people are asked to nominate further people known to them so that the sample increases in size. For example, if I was selected for the population, I would recommend a family member or a friend. The problem with snowball sampling is that there is high bias because the person being selected might have similar traits, but snowball sampling is really useful when the sampling frame is difficult to identify for your population. I hope this was informative. To learn more about data science, please visit ralphfabric.com. Thank you and have a nice day.